Let us now know the DNF form or the disjunctive normal form for a Boolean expression. Okay, here I have taken a Boolean expression in n Boolean variables. Look at my cursor. This is alpha of x1, x2, so on, xn. This is a Boolean expression of n variables, n Boolean variables x1, x2, so on, xn. If we can express these Boolean expression, if we can express this Boolean expression, if we can express this Boolean expression alpha of x1, x2, so on, xn in this form, alpha equal to alpha 1 plus alpha 2 plus so on alpha m. Here, as I have written this alpha 1, alpha subscript 1, alpha subscript 2 and so on, alpha subscript n, these are nothing but the mean terms. These are nothing but mean terms in these n variables x1, x2, so on, xn. That means alpha 1 is a mean term of these n variable x1, x2, so on, xn. Alpha 2 is a mean term of these n variable x1, x2, so on, xn, and so on. This alpha m is also a mean term of this n variable x1, x2, so on, xn. That means, so what does it imply? A Boolean expression alpha of x1, x2, so on, xn will be termed as a disjunctive normal form. That means this very Boolean expression is in DNF form or disjunctive normal form when we can be able to express this Boolean expression in the sum, when we can be able to write this very Boolean expression as the sum of some mean terms of in these n variables x1 to xn. Okay, you everybody know what is the mean term. In your previous class I have told you, in my previous video I have told you, that means part 1, in part 1. So this is x1, x2, so on, x1 into x2, x1 tilde into x2 tilde into x3 tilde, so on, into xn tilde. This product form is a mean term in n variable x1 to xn. Tilde means that here is either x1 is present or x1 complement is present. So tilde actually implies the variable original Boolean variable there may be, or the complement of that very variable there may be present. Okay, and this being in product form, so sometimes we may call that this very Boolean expression when is expressed in DNF form, this form sometimes we may call that this is the sum of product form, because this is the sum, and each and every member alpha 1, alpha 2, so on, alpha m being a mean term, we can call obviously that the sum of a product term, this product term, each of these alpha 1, alpha 2, so on, alpha m being a product term, we may call that this is the sum of a product term. Okay, so let us now take an example and express that very Boolean expression. Let us now take an example. Here I have taken this very Boolean expression alpha, which is basically x1 complement plus x2 into x3, and we shall express this very Boolean expression in DNF form or disjunctive normal form. That means in this form, the sum of product form, sum of some mean terms. Okay, actually in fact in your examination there will be given such a Boolean expression, and you will be asked to write down the DNF form of that very function or of that very Boolean expression. That means that very Boolean expression you have to express in DNF form. Okay, here I have taken an example. This is the Boolean expression alpha equal to x1 complement plus x2 into x3, and I shall show how to express this very Boolean expression alpha equal to x1 complement plus x2 into x3 in DNF form. Okay, so first I have constructed the assignment table or value table. Carefully note this, assignment table or value table. Sometimes it may call the truth table. truth table. I am skipping that very term because specifically here I am litigating with abstract algebra. Okay, so I shall use the very abstract sense terms. Okay. In that very sense, I am constructing the very assignment table or the value table for this very Boolean expression. So let us now see. This alpha is a Boolean expression in three variables: x1, x2 and x3. This is x1 complement plus x2 into x3. I have constructed the very assignment table, and for each and every assignment of this three tuple point x1, x2, x3, for each assignment I have considered a name: row 1, row 2, row 3, row 4, row 5, row 6, row 7 and row 8. This being a Boolean expression in three variables, and obviously as we know from our previous classes that there we can assign 8 possible assignment for these x1, x2 and x3. So I have renamed that very assignments, each and every assignment, as row 1, row 2, row 3, row 4, row 5, row 6, row 7 and row 8. Okay, and the corresponding assignments I have written here in this very first row: x1 1, x2 1, x3 1, the values of the Boolean variable. x1 complement being the complement of 1, obviously would be equal to 0, and x2 into x3, this is 1 into 1, this is equal to 1, and alpha being the sum of x1 complement and x2 into x3, that means x1 complement plus x2 into x3, and obviously this would be 0 plus 1 equal to 1. I have written here that very. Okay,